In this section, we're going to talk about square roots. First, let's talk about the square of a number. So, for example, we look at the number 3 times 3 is equal to 9. Typically, we say that 3 squared, because any number times itself is the square of a number, so 3 squared is equal to 9. What we want to know is what can we do to 9 to get 3? And that's where the square root comes in. So if we take the square root of 9, then the number should equal 3. Notice that this represents the symbol of a square root, and that there's an understood 2 here when it's not shown. So what we see is that the opposite of squaring a number is taking its square root. Alright, so the opposite of squaring a number is taking the square root. Let's look at some examples. Let's take the square root of 25. So what we're asking ourselves is what times itself equals 25? We notice that the square root of 25 is 5. Here's another one. Let's say we had negative the square root of 49. In this case, we're going to take the square root of 49, which is 7, and we're just going to simply put a negative on the outside because it is on the outside of our square root symbol. Okay? So this is negative 7. However, if we put the square root on the inside, then we would not be able to solve our problem so easily. Because what this is asking is what times itself gives me a negative 7. And we know that whenever we square a negative number, a negative 7, for instance, times a negative 7 gives us a positive 7. So if we were to try to look at, let's get rid of the sign here. If we were to try to look at negative 7 times a negative 7, it would give us a positive 49. And, of course, a positive 7 and a positive 7 would give us a positive 49. So in this case, no number times itself would give me a negative 49. Now remember, so this is not or has no real solution. This has no real solution. Now remember that the two numbers, negative 7, for instance, and negative 7 had to be the same. We couldn't choose a negative 7 and a positive 7 because those are two different numbers. If you look at the number line, it will prove that to you. All right, let's try another example. What about the square root of 16 over 49? So in this case, what we're going to do is take the square root of the top and the square root of the bottom. In doing that, we'll end up getting the square root of 16 is 4. The square root of 49 is 7. So our answer is 4 over 7. Alright, you try this one. What is negative the square root of 100? Okay. So negative the square root of 100 is 10, or negative 10 in this case. Very good. Okay, let's look at this one. Here we're given negative 5 the square root of 36. In this case, the negative 5 times the square root of 36, we said before, is the 6. So negative 5 times 6 is negative 30. Okay? Here's another example. The square root of 81 minus the square root of 9. See if you can do this. Okay, the square root of 81 is 9, minus the square root of 9 is 3. So 9 minus 3 is 6. Last one, you take 64 minus 13 times 3. Go ahead and try this. Okay? So what you want to do here is simplify everything underneath the radicand here. So what we're going to do is take the square root of 64 minus 39. Then the 64 minus 39 will give us 25. And the square root of 25 is 5. Not so hard, huh? Next, we're going to break the numbers up into 3 different categories. The first category is a rational number. The next one we see here is irrational. And the last are those type that have no solution. Let's talk about rational numbers. Whenever we're given something that has a perfect square, so if it has a perfect square, we're going to consider it to be rational. So for example, if I say, what is the square root of 25? It has a perfect square of 5. If I say the square root of 1/9, it has a perfect square of 1/3. Okay, so all of these are considered to be perfect squares, and therefore they are rational. Sometimes you're going to be given irrational numbers. Irrational numbers are numbers such as numbers that do not have perfect squares. Alright, if it does not have a perfect square, it would be an example like the square root of 11. You can't simplify, there's no two numbers that multiply together to give me 11. Or, excuse me, let me say that better. There's not one number that I can multiply to itself that will give me 11. Alright, so the square root of 11, or the square root of 3, the square root of 26, none of these are perfect squares, therefore they are irrational. The last one are numbers that do not have real solutions. And we said before, whenever we take the square root of an even number, or the square root of a negative number, then it has no solution, no real solution. So the square root of -2, the square root of -4, the square root of 7, -7. All of these have no real solution. They are neither irrational nor rational. Alright, let's look at these examples. Try to state the category for each one of these. Press pause so that you can do that. Okay, so the first one, the square root of 12. The square root of 12 is not a perfect square, so therefore this is irrational. The next one, the square root of 144. Well, I know that 12 times 12 equals 144. Therefore, this is equal to 12, and it is rational. The last one, we're taking the square root of a negative number, in this case, negative 54, and it has no real solution. Okay? All right, the next thing we're going to talk about is the idea of canceling the square root and the square out. For example, if I take the square root of 2 squared, if I look at what's inside the radical, I'll see that 2 squared is equal to 4. And the square root of 4 is 2. So what we could have done is just simply cancel out the square and the square root, and we would have been left with the number 2. So let's try that one more time. Let's look at the square root of 4 squared. Well, this time, since I know that I can cancel the square and the square root out, I'm going to cancel the 2 and the square root, and I'll be left with the number 4. Okay? So you try this one. What is the square root of 28 squared? Hopefully that's right. So here, the square and the square root cancel, and you get 28. Now, this is true when there's numbers, you can easily see what's going on. The problem is, we said that whenever we have the square root of a negative number squared, things get a little different, happen a little different. So here we see that negative 2 squared is 4. But the square root of 4 is 2. So whenever we have a square and a negative term that's being squared, what we're going to end up with is the absolute value when we cancel these two out. We're going to end up with the absolute value of negative 2, which will be 2. So we have to keep that in mind. This really only works when we have even roots. Okay, so an even root just means that this is the square root, not the third root of, or the cube root of. All right. So let's try this example. Here you're given the square root of 81x squared. So now we're introducing a variable. We have to be particularly careful when we have variables involved to use the absolute value. When it's just a number, it's not as big of an issue. So we said that the square and the square root cancel each other out. We're left with the absolute value of 81x. I use the absolute value because I don't know whether the x is going to be a positive number or a negative number. Likewise, this can end up being 81, the absolute value of x. You can keep it either way. I don't think most people care which way you have it. Let's try one more. The square root of a plus 4 squared. See what you come up with. Very good. So here, you canceled out the square and the square root, and you were left with the absolute value of a plus 4. Okay? Thank you very much.